Hello viewers, I am back with another series of video that is based on definite integrals. I had explained you what is the meaning of definite integral and how to solve a definite integral when the limits are given or the interval is given. In today's video, I would explain you how to use the properties of definite integral to solve the problems based on definite integral. I suppose you all have understood the concept of definite integral and you have solved some problems so that you can understand my this video which is based on the properties. Before I proceed with the video, I would like to inform you or I would like to remind you to subscribe my channel and share with your friends in the social media as well as in the WhatsApp or whatever friend circle you have, so that more and more friends of yours can be benefited through this video and I can understand what are your needs. Accordingly I can proceed. तो चलिए हम समझते हैं डेफिनेट इंटीग्रल्स के प्रॉपर्टीज. तो पहला जो प्रॉपर्टी है इंटीग्रेशन ऑफ a to b f of x dx equal to integration of f of t dt. ये पहला प्रॉपर्टी. This means that definite integral is independent of the change in variable. Independent of the change in variable. That means if the derivative of phi x is fx, that means the integration of fx is phi x, or we can say that derivative of phi t is equal to f of t. So if I use the concept of definite integral, integration of fx dx a to b is equal to phi b minus phi a. Same way, integration of a to b f of t dt is also phi b minus phi a. So comparing 1 and 2, our property is proved. So a to b f of x dx is same as a to b f of t dt. This shows that suppose we have integration of say x dx, say minus 1 to plus 1. Its answer will be x square by 2 minus 1 to plus 1, that will be 1 by 2 plus 1 by 2, that is 1, and minus 1 to 1 t dt, this will be also half plus half, this will be also 1. This shows that the definite integral is independent of the change in the variable. So let us see the next property in the next section of the video. So our next property is integration of a to b fx dx is equal to minus b to a fx dx. That means the value of the definite integral changes if the position of the upper limit and lower limit is changed. That means if the lower limit is made upper limit and the upper limit is made lower limit, then the value of the definite integral changes by a negative sign or a minus sign. Let us understand this concept with the help of an example. That is, if integration of say x cube dx from 0 to 2, we have to integrate this. Then this means what? X to the power of 4 by 4, 0 to 2. This is when we have substitute the value 2 to the power of 4 by 4 minus 0, and that is equal to 16 by 4, that is 4. And if I change now the position of the lower limit and upper limit, that is 2 to 0 x cube dx, when it is x to the power 4, integration you can say 2 to 0. This is equal to 0 minus 2 to the power 4 by 4. Obviously it will be minus 4. So what we observe is the value of the integration, definite integration, changes with a negative sign. So directly we could use this property in some places and directly write the value of this as minus of this integration. So this was property number 2. Now let us move on to the next section of the video to understand property number 3. Now property number 3. So what is the property? So integration of a to b f of x dx is equal to a to c f of x dx plus c to b f of x dx, where c is an intermediate point in between a and b, where c is an intermediate point between a and b. What does this mean? That means if we could find a number in between the interval a and b, then we could write this integration a to b f x dx as a sum of two integrations. So let us take this right hand side, a to c fx dx plus c to b fx dx. Suppose the integration of fx is phi x, then phi of c minus phi of a, that is the integration value of a to b fx dx, plus integration of fx is phi x again, so it is phi b minus phi c. So phi c gets cancelled, so we get phi of b minus phi of a. The left hand side is also same thing, a to b fx dx. Integration of fx is phi x, so we will get phi of b minus phi of a. This means that if we get a number in between in between the intervals a and b, then we could write the given definite integral as two parts, a to c fx dx plus c to b, means c is continuing. If we could get another value in between c and b, say d, then we could have written again a to c plus c to d plus d2b. So we could write into three parts or three integrations, and this will help us to solve the definite integral easily. When we see the examples based on this definite integral, I think you will understand the properties much better. Now let us only understand the properties. Its use we shall see in the next video. So let us move on to the property number 4. Property number 4. Property, we have already understood three properties. Now this is the fourth property, that is a to b fx dx is equal to a to b f of a plus b minus x dx. That means the integration of fx from a to b dx is same as integration of a to b. Then if x is replaced by sum of the limits minus x dx, it gives the same result. Let us understand its proof. Let x is equal to a plus b minus t. Then dx is minus dt. When x is a, b is t equal to b, and when x is b, t is equal to a. Now putting the value in the left side, that is instead of a I put b, instead of b I put a, minus f of, in place of x I put a plus b minus t. And why minus I put? Because dx is minus dt. This is same as a to b f of a plus b minus t. This I have changed the position of the limits, so the value of the definite integral changes by the minus sign. So this minus is removed, and this is equivalent to a to b f of a plus b minus x dx, because the definite integral, value of the definite integral is independent of the change in variable. So t has been replaced by x. So we get the property number 4. Now property number 5 is the extension of property number 4. That is 0 to a fx dx is same as 0 to a f of a minus x dx. What does this mean? See, here in this property we had a to b, and here we have 0 to a. That means according to property number 4, we can write 0 to a fx dx as 0 to a f of a plus 0 minus x dx, and that is equivalent to 0 to a f of a minus x dx. That means let us take an example. If we have 0 to pi by 2 sin x dx. Here a is 0, here 0 and a is pi by 2. So this is same as 0 to pi by 2 sin pi by 2 minus x dx, or this is equivalent to 0 to pi by 2 cos x dx, because sin 90 minus theta is cos theta. So 0 to pi by 2 sin x dx is same as 0 to pi by 2 cos x dx. This is the utility of property number 5. So when it is given 0 to pi by 2 sin x dx, we can use it to write the same 0 to pi by 2 cos x dx. Let us move on to the next property, property number 6. Our final property, that is property number 6, minus a to a fx dx is equal to twice 0 to a fx dx if fx is even and 0 if fx is odd. So let us understand the property. Now this could be written as minus a to a fx dx as minus a to 0 fx dx plus 0 to a fx dx. Now if we take, let x is equal to minus t, then dx equal to minus dt. Then minus a to 0 fx dx is written as, when x is minus a, t is a, and when x is 0, t is also 0. That is minus f of minus t dt. How it is minus? Because dx is minus dt and in place of x it is minus t. So this is also equal to 0 to a f of minus t dt. Hence we can write minus a to a, or this is equal to 0 to a f of x dx. So minus a to a fx dx equal to twice 0 to a fx dx if fx equal to f of minus x, and equal to 0 if fx equal to minus of f of minus x. So why it is so? Because if these two are equal, then these two integrations become same. So this two integration becomes same. If this two integration is same, then it is twice of 0 to a fx dx. And if one of them is a negative of the other one, then we get both of them cancels and we get 0. And this is possible if it is even function. And this is possible if it is odd function. So what is the property? This is a very important property we quite often use in our problem. That is integration of fx from negative interval, negative of minus a, to positive of a is equal to twice the integration of 0 to a. Means in between minus a and a we have the number 0. So 0 to a fx dx if the function is even. If the function is even means fx equal to f of minus x, and equal to 0 if the function is odd. When is odd? When fx equal to minus of f of minus x, or f of minus x is equal to minus fx. We can also say it in this way, f of minus x equal to f of minus of fx. This is odd function. If it is odd function, the value of this integration is 0. If it is even function, fx is even function, then it is twice of 0 to a. In this context, I would like to say an example of odd function is sin x, and example of even function is cos x. Or we can write fx is equal to x square is an even function, or fx is equal to x cube, it is an odd function. So these were the properties of definite integral. I suppose all the properties, all the 6 properties are well understood by all of you. मुझे आशा है कि जो प्रॉपर्टी मैंने बताया है वो सब आप लोग को समझ में आया होगा, क्योंकि इस प्रॉपर्टी के आधार पर हम जो प्रॉब्लम्स आगे आने वाले हैं वो सब प्रॉब्लम्स हम सॉल्व करने के लिए हमारा सुविधा होगा। तो पहले हमें इस प्रॉपर्टीज़ को बहुत अच्छा से समझना होगा, तभी हम इसके प्रॉपर्टीज़ का इस्तेमाल हम अपने प्रॉब्लम्स में कर सकेंगे। तो जो भी आपका कमेंट्स हो, काइंडली अपने कमेंट बॉक्स में मेंशन कीजिए और अगले वीडियो के लिए इंतज़ार कीजिए। थैंक यू एंड बाय बाय।